Now we are going to have continuation of integration. We explained last time integration by substitution. We have one more rule of integration by parts, right? The rule of integration by parts, it is a rule given in the formula sheet. It's called integration by parts. Integration by parts. Whenever you see a problem where you have to integrate x cosine x, you have to integrate dx, you have to integrate x e power x dx, you have to integrate x ln x dx or x squared ln x dx. All of these are called, it is done by parts because there are two parts, and that's why we call it integration by parts. Integration by parts has a rule. The rule is written in the formula sheet. It say this. The rules say this. The integration of u dv by dx is equal to uv minus the integration of v du by dx. This is the rule. For example, we apply this rule. We apply the rule to the first example, which is integration of x cosine x dx. Right? Now, the rule, we are going to tailor the problem to the rule, which means u would be equal x and dv by dx will be equal cosine x. Therefore, we say this u equal x and dv by dx equal cosine x. If u equal x, then what is du by dx? Du by dx will be equal 1. If dv by dx equal x to cosine x, to get v means we integrate. What is the integration of cosine x? Is sine x. Then we apply the rule above, and we say the integration equal uv, u is x, v is sine x, minus the integration of, the rules say v, which is sine x, times du by dx, which is 1 dx. Therefore, the answer is x sine x minus the integration of sine x, and the integration of sine x is minus cosine x. We can use the minus outside, therefore we say plus cosine x plus c. This is how we applied the rule. We take another example. Let us take an example of the integration of x e power x dx. Then we are going to say the u is x and the dv by dx is e power x. Therefore, du by dx is 1 and v equal e power x. We just apply the rule, we get the answer. The integration equal to uv x e power x minus the integration of e power x times 1 dx. Therefore, the answer is x e power x minus e power x plus c. Now we go to the next example. Let us integrate x square ln x. Now, to integrate x square ln x dx, here there is a base for the choice of the who is u and who is v. If any term in the integration cannot be integrated, then it must be taken as u. If both terms can be integrated, then we use the algebraic one, which is x or x squared is u. Again, the rule. If any of the two terms cannot be integrated, then it is u. If both can be integrated, then we take the term containing x is u. In this problem, ln x cannot be integrated, and therefore we are going to choose u is ln x. And dv by dx, or v dash, is x squared. Then u dash is 1 over x, and v equal x cubed over 3. Then we say the integration equal uv, which means x cubed over 3 ln x, minus the integration of vu dash x cubed over 3 times 1 over x dx. Therefore, it is x cubed over 3 ln x minus the 1 over 3 outside, the integration of x squared dx. Always when there are numbers, it is very, easier way to take how it is advantage, how we prefer that we take the numbers outside to get rid of the numbers, therefore don't worry about them in integration. And therefore this is equal to x cubed over 3 ln x minus 1 over 3. What is the integration of x squared? X cubed over 3 plus c. And therefore the answer is x cubed over 3 ln x minus x cubed over 9 plus c. Another example. This example, we are going to try to integrate x squared e power x dx. Here, both can be integrated. Since both can be integrated, therefore we take u is x squared. By u is x squared. And v dash is e power x. By u dash is 2x. And v equal the integration of e power x is e power x. But therefore our integration equal to the integration equal to the integration the integration equal to uv x square e power x minus the integration of vu dash e power x times 2x dx. This is again a problem which has to be done by parts. The second part here, it has to be done by parts, therefore we do it here on the side. We say u is 2x and v dash is e power x. U dash is 2 and v equal e power x. Therefore this is equal x square e power x minus, now we are applying this, the rule by parts for this one using this information. The rules say uv, which is 2x e power x minus the integration of, right, v e power x times u dash is 2 dx. Therefore it is equal x square e power x minus 2x e power x minus plus 2 e power x plus c. Right. Therefore, we call any problem containing x square and cosine x, x square, sine x, x square, e power x, that we are going to do integration by part twice. We say this, we are going to do integration by part twice. Except x square ln x. This is not twice, this is once only. Why? Because we take ln x as the first term, u. Therefore, it is done only once. We have another type of problem, very nice, right? A tricky problem. If we say we want to integrate, right, now from 1 to 2 of ln x alone dx. Now we cannot integrate ln x, and therefore what to do is we do the trick. We just say that this is equal the integration of ln x times 1 dx, and we do it by parts. We consider the first term u is ln x and v dash is 1. U dash is 1 over x and v is x. And we continue and we say the integration equal. The rules say v u times v, x ln x minus the integration of v times u dash, 1 over x dx. The answer is x ln x minus the integration of 1 dx. This will be x ln x minus x. By the way, this is the integration of ln x. Integration of ln x is x ln x minus x. Now we have a limits from 1 to 2. We substitute 2 ln 2 minus 2 minus 1 ln 1 minus 1. Ln 1 is 0. Therefore, this is 2 ln 2 minus 2 plus 1. Therefore, the answer is 2 ln 2 minus 1, which we can say it is ln 4 minus 1. is the examples about integration, right, by parts. Quickly we can have another example, right? Let us integrate x squared sine x dx. From the beginning we know that we are going to do integration by part twice. The first part we are going to say u equal x squared and v dash is sine x. U dash is 2x and v equal negative cosine x. Therefore this integration equal to uv minus x squared cosine x minus the integration of v, which is minus cosine x, times u dash, which is 2x dx. This is a new problem by parts. Anyway, the minus becomes plus, and therefore this will have a new problem by parts, in which we are going to say the u is 2x and the v dash is cosine x. But the u dash is 2 and the v equals sine x. Therefore this is equal to negative x squared cosine x plus, now we open bracket, we had the integration of 2x cosine x, right? The rules say uv equal 2x sine x minus the integration of v, which is sine x, times u dash, which is 2 dx. This would be negative x squared cosine x plus 2x sine x. Then the integration of negative sine x is cosine x, equal plus 2 cosine x plus c. This is the end of integration by parts. Now we have one last type of integration, right? Now, which is, we know that if we differentiate means d by dx of a power x, the answer is a power x ln a. But the opposite is true. When we integrate a power x dx, a power x dx, the answer is a power x divided by ln a plus c. Therefore, if I ask you what is the integration of 5 power x dx, you say to me 5 power x over ln 5 plus c. And that is the last rule of integration. Now we have numerical integration, or what we call the trapezium rule. Right. Now, the trapezium rule we took in the S, but here we just repeat it, and we should remind you that you are going to make the table yourself. We know that if we are asked to integrate a function f of x dx from a to b, and this is the function, right, from a to b, like this, and we asked to integrate from here This is A to this B. It will be given to us the number of strips. It will be mentioned in the question using n strips. Straight away we are going to find what we call the width of each strip, h. h equal b minus a over n. Therefore we have the width of each strip. The width of each strip. Therefore this is h, h, and so on. These are the widths of the strips we have. The width of each strip, this distance here, is h. Accordingly, we are going to make a table. In this table, we are going to put values of x and f of x. We start with x equal a. The next value is a plus h. The next value of x is a plus 2h, and so on, until the last value, right, b. We will get values of y. This is called y0, y1, y2, and so on. The last one is yn. The rules say this, that the integration, this is numerical integration, equal h over 2, open bracket, the first y plus the last y plus twice all the other y's in between, y1 plus y2 plus y3 until the y before the last. And this gives us what we call the numerical integration. Numerical integration means something we cannot do numerically, and that's why we have to make it in table. We have to make it numerically, and we calculate it numerically. Let us have an example. In the example, let us say we wanted to do integration of, right, from 0 to pi over 3 of sec x dx. And we were asked to do it, right, using, okay, now it says in the question, right, now 4 strips, using 4 strips. Therefore we got the value of h equal pi over 3 minus 0 over 4, which means pi over 12. Therefore we make our table. The table is the value of x and the value of f of x, which means y. Right, we can call it better, we call it y. Therefore we're going to call this y. Now, we start with the value, right, of x equal to 0. Then the next value is 0 plus pi over 12, pi over 12. Then the next value is 2 pi over 12, which means pi over 6. The next is 3 pi over 12, which means pi over 4. And the last is 4 pi over 12 means pi over 3. And we are going to calculate the values of sec x. Sec 0 is 1. Take that number is 1.035. That number is 1.155. That number is 1.414. And this number is 2. Say we say the integration, we write I or the sign of integration. I equal h, which is pi over 12, divide by 2, open bracket. The first y is 1, plus the last y is 2, plus twice the other y is 1.035, plus 1.155, plus 1.414. These values of y times 2. We calculate this. Pi over 24 times, after we add 1 plus 3 plus twice these values, we get altogether 10.208. We multiply it times pi over 12, we get the answer is 1.3362224 and so on. Now it will be mentioned in the question to write the answer to how many significant figure. Let us say 3 significant, then the answer is 1.342 3 significant figure. Now, there is just one comment, right? Then, by the way, we know that if we increase the number of strips, the answer will be more accurate. The accuracy of the answer will increase with the number of strips. Because as we increase the number of strips, the difference between, because we have two possibilities. If our graph is like this, or if our graph is like this. If our graph like this and these are our strips now, and we are calculating the trapeziums, the area of the trapeziums is less than the exact area, and accordingly we say our answer we get is less than the exact answer. We call this underestimation. Therefore, our answer is an underestimation. And if we have this case here, the trapeziums are like this, then our trapeziums is more than the exact area. Therefore, our trapezium will give an overestimation. Increasing the number of trapezia, this will reduce the difference between the lines and the curve and give the answer more accurate. Now we are going into applications of integration. Applications of integration. Or uses of integration. Applications of integration. There is one application we already know. This application we already know is that if this is a curve and you want to get the area under the curve from A to B, this area, we say this area equal to the integration of y dx. The new thing in the A level is this. When you have an area like this, and this area is rotated between A and B, and this area is rotated about the x-axis, we are going to get a solid of revolution. If the area is rotated about the x-axis, we form a solid. Therefore, we say we want to get what is the volume of the solid of revolution. The way to get it is that we integrate by y squared dx. Usually we take the pi outside and we integrate y squared dx. Therefore, we have two usual applications we can be asked. One is called how to get the area under the curve, and the other one is how to get the volume of the solid of revolution. The area under the curve, the usual integration of y dx, and the volume of the solid of revolution, which is the integration of y squared dx, then multiplied by pi. Now let us take an example. The example we take, we are going to have, right, y, the curve is y equal sine 2x. Y equals sine 2x, and it is, we are going to look between 0 and pi over 2. And 0 and pi over 2, when x is pi over 2, then to be sine pi, which means this is a graph, all the graph like this. Now x here is 0 and x here is pi over 2. We are asked to find two things. What is the area under the curve? Then what is the volume of the solid of revolution when this area is rotated? First, we want to get the area. This, right, we call it region, say R. What is the area? Right, we want to get the area of R. We say this equal to the integration of y dx and the limit from 0 to pi over 2. Therefore, we are going to integrate from 0 to pi over 2 y, which is sine 2x dx. Now, this would be equal to, what is the integration of sine 2x? The integration of sine is negative cosine. Even negative cosine 2x, and we divide over the number in front of x over 2. And we put the limits from 0 to pi over 2. This is equal to, right, negative half. What is this? The cosine of 2 times pi over 2. You have a cosine pi minus, we substitute 0, divide, I put up minus half cosine 0. This is equal to, cosine pi is negative 1. but this is half plus half. The answer is 1. Therefore, this area is 1. Now we are asked that the area R is completely rotated about the x-axis to find the volume of integration, our volume of solid of revolution. Right, we can call it volume of solid of revolution. Right, this is a correct wording. Right, it says find the volume of the solid of revolution. Now, we are going to say the volume equal pi the integration of y squared dx, pi the integration of y sine to x, yani sine squared to x dx, and the limits from 0 to right. Now, from 0, we go back to the page. X is pi over 2, and the limit is from 0 to pi over 2. Now, we know that the integration of sine square, we have to convert it using the rule of double the angle. This would be the integration of half, open bracket, 1 plus 1 minus, because this is sine square, 1 minus cosine double the angle for x dx. Therefore, it will be pi over 2 outside, and we are going to integrate 1 minus this. The integration of 1 is x minus sine 4x over 4. And we put the limits is from 0 to pi over 2 equal pi over 2 into pi over 2 minus the sine of 4 times pi over 2. 4 with 2 is 2 pi. Sine 2 pi sine 360 is 0. Minus, we substitute 0. 0, and sine 0 is 0. Therefore, the answer to this integration is going to be right. Pi square divided by 4. And this is the volume of the solid of revolution. This is the volume of the solid resulting of evolution. Fine. This is applications of integration. Now, I should remind you of one thing. If in a problem we have a curve, and this is the normal. And then it was asked that we should get the volume of solid of revolution of this area. Then we are going to divide this into two parts, area A1 and the area A2. I mean, what is the volume when area A1 is rotated? The volume V1 is, of course, it is pi the integration of y squared dx. But the volume V2, it is the volume of a cone. This cone has this height is the radius, and this is the height. Therefore, we have a volume of a cone, and this would be the radius, and this is the height. And it will be mentioned in the question how to get the volume of a cone. The volume of the cone is 1/3 pi r square h. Now, we are going to go into one other, type of integration in general, is the integration of parametric equation. What we call integration if the equation is parametric. What we do if the equation is parametric. For example, if we have a curve x equal r into 1 plus r, or t into 1 plus t, the parameter is t, and y equal 1 over 1 plus t, and we is given to find the area. We want to get the area, for the area between x equals 0 and x equal 2. Now, we are going to say this: when x equal 0, now when x equals 0, then t, if 1 minus t equals 0, therefore either t equals 0 or t equal -1. And it says in the question, in t is greater than 0, therefore we take, or equals 0, therefore we take t equals 0. Then when x equal 2, then we have t, if 1 plus t equal 2, that means t squared plus t minus 2 equals 0. which means t minus t plus 2 if t minus 1 equals 0. Therefore, either t equal negative 2 rejected and t equal 1. This is rejected, but t equal 1. Therefore, we know the limits of integration. Our limits of integration are from 0 to 1 regarding the t. Now we say this. What is the area? Area equal to the integration of y dx. But the problem that y is not in terms of x. Therefore, we're going to make a trick. We're going to say y dx by dt dt. This is what you do every time you have the equation parametric in area and in volume. Rather than saying y dx, you write dx equal dx over dt dt. And in the volume y squared dx, again dx equal dx by dt dt. And therefore we integrate this, the integration of y, which is 1 over 1 plus t, times, this is y, times dx by dt. We differentiate dx by dt. Dx equal t plus t squared. T plus t squared, differentiation is 1 plus 2t dt. Therefore, we have to integrate 1 plus 2t over 1 plus t dt. Now, we need to make, this is an improper fraction. Therefore, we need to make a long division of 2t plus 1 divided by t plus 1. We get 2, we get 2t plus 2, then we get negative 1. Therefore, the answer is 2 minus 1 over t plus 1. We continue in the next page. This would be the integration of the integration of 2 minus 1 over 1 plus t dt, and the limits of t is from 0 to 1. Integrate 2 is 2t. If we integrate t, we get 2t minus ln 1 plus t. And we put the limits and this is modulus. And the limits is from 0 to 1. We substitute 1 first, and then we substitute right 0. We get 2 times 1 is 2, minus ln 1 plus 1 is 2, minus 0 minus ln 1 plus 0, 1, which this is 0. Therefore, the answer is 2 minus ln 2. If we were asked also to find the volume of revolution for the same problem, if we would say that the area is rotated, complete rotation, therefore how to get the volume? By the integration of y squared dx, therefore make the integration of y squared dx by dt. Therefore equal to y squared is going to be equal to 1 by outside the integration of y squared is 1 over 1 plus t squared. Right? Dx by dt, again the differentiation of dx by dt is 1 plus 2t dt. Okay? dt. dt. Now, how we are going to do this integration? What is this in actual fact? It is by outside the integration of the integration of 1 plus 2t over 1 plus t squared dt. And this is a problem of partial fraction. Therefore, we need to make one out 2t plus 1 over t plus 1 squared equal a over t plus 1 plus b over t plus 1 squared. This is how we do this partial fraction. We are going to multiply time this, so we get 2t plus 1 is identical to a times t plus 1 plus b. We substitute, right, now t equals 0, we got t equal 1 first, equal negative 1. We substitute t equal negative 1. T equal negative 1, but negative 1 equal. T equal negative 0 equal b. Then we substitute t equals 0. Then we get 1 equal a plus b. Therefore, 1 equal a plus b, and b equal negative 1, therefore a equal 2. Therefore, we get the values of a and b. Therefore, our integration would be the integration of 2 over t plus 1 minus 1 over t plus 1 squared, right, dt, and outside is pi. And the limits is from 0 to 1. This is equal to pi outside. It is 2 ln t plus 1 minus, this is t plus 1 to the power negative 2, t plus 1 power negative 2, its integration is t plus 1 power negative 1 over negative 1, and the limits is from 0 to 1. That is equal to pi into 2 ln t plus 1 plus 1 over t plus 1. We substitute the limits from 0 to 1. We substitute pi outside, 1 first, 2 ln 2 plus 1 over 2 minus 2 ln 1 plus 2 ln 1, okay, right, plus 1 over 1. Therefore, pi outside into 2 ln 2 plus half minus 1, 2 ln 1 be 0, but minus 1. Therefore, the answer is pi outside into 2 ln 2 minus 1. You can leave it like this, or you like to write it as ln 4 ln the number 4 minus 1, or you leave it as 2 ln 2. It's all the same. This is the end of this example. Now we are going to go into something else. Something we call differential equation. Differential equations. Now, every time we have an equation containing differentiation, containing dy by dx, and we wanted to get y, then we call it differential equation. Every time we have a problem containing differentiation and we are getting y, this is called differential equation. For example, if we have the equation dy by dx, right, equal, now 2xy. This is a differential equation because this side contains differentiation. We cannot say y equal the integration of 2xy. Why? Because how do we integrate 2xy? And y is unknown. Therefore, there is certain steps to be done. What are these steps? The first step is called, we have to do separation of variables. What do you mean separation of variables? That you put all the y in one side and the x in one side. Therefore, we are going to say 1 over y dy equal 2x dx. That's it. The variables are separated. One side is y and one side is x. The next is we put the sign of integration in both sides. 1 over y dy is the integration of 2x dx. What is the integration of 1 over y dy? It is ln y. And what is the integration of 2x is x squared plus c. Therefore, y equal e to the power x squared plus c. We are going to say this is equal e power x squared times e power c. We are going to call e power c is a e power x squared, where a is unknown. We can get the value of a once some information about x and y are given. This is called the general solution. We call this the general solution. We call it the general solution of differential equation. Now let us have another example. Now, let us have the example, this example. 1 plus, well, given that 1 plus x squared dy by dx equal x tan y. Now, here again we have differential equation. It contains differentiation. We said the first step is to separate the variables. Therefore, we get 1 over tan y dy equal x over 1 plus x squared dx. Therefore, the variables are separated. 1 over tan y means cotan y, and cotan y means cosine y over sine y dy equal the integration of x over 1 plus x squared dx. Then we say this. What is the integration of this? The cosine y is a differentiation of sine. يبقى ln sine y equal, again, this is the differentiation of this, but 2 is missing. يبقى half ln 1 plus x squared plus c. When the equation all contains lns, like here, then we call the c ln a. Therefore, we're going to say this ln, we're going to say ln sine y equal ln the square root of 1 plus x squared plus ln a, which means ln a square root of 1 plus x squared. The ln cancel with ln, we give us then that sine y equal a the square root of 1 plus x squared. And this is called the general solution of this differential equation. Now, we can make the general solution particular solution by giving the value of x and we get the value x and y, and we get, right, the value of a. This, in that case, we will be able to get the value of a, and therefore we have a particular, right, integral. Now, we could be given, for example, that when x equals 0, say it is given that x equals 0, right, y equal, okay, when x equals 0, y equal pi over 2. Therefore, sine pi over 2 equal a root 1, and sine pi over 2 is 1. This means a equal 1, and therefore we got the equation sine y equal the square root of 1 plus x squared. We can have a situation like this. The differential equation is not given, but we are given a description in words. For example, it says here the rate of increase. It says this: the rate of increase of population right, of micro, right, organism at time t is proportional to the amount of, right, to the amount present. In that case means the amount of bunker to the amount present. Right. Given that at t equals 0, the amount is 8, and at t equal 1, the amount is 56. Find the amount when t equal 2. You remember in the O level, when we say y proportional to x, يبقى y equal kx. Let us call the population is p. يبقى dp by dt equal k times p. It says proportional to the amount. K is the constant of proportionality. Separation of variables, we get 1 over p dp equal k dt. The integration of 1 over p dp equals the integration of k dt. Ln p equal kt plus c. Now we substitute at t equals 0, population is 8. يبقى ln 8 equal t equals 0 c. Therefore, ln P equal KT plus ln 8. يبقى ln P minus ln 8 equal KT. يبقى ln P over 8 equal KT. This means P over 8 equal e to the power KT. Therefore, P equal 8 e to the power KT. Then we substitute t equal 1, it is 56. At t equal 1, P is 56. Yibba 56 equal 8 e to the power k times 1. Yibba 7 equal e to the power k. Taking ln both sides, yibba k equal ln 7. Okay. He asked what the amount when t equal 2. P equal 8 e to the power k times 2 means 8 e to the power 2 ln 7, which means 8 e to the power ln 49. Therefore, this is equal to 8 times 49, and we got the answer is 392. And this is the end of integration, right, completely, and integration and application and differential equation.